One of the most important consideration and parameters in project management is timing. That's how much time you have to finish an activity or to delay finishing an activity, but still be able to finish doing a project and completing a project on time. To gain this perspective of timing, the correct timing of those activities in a project, we need to talk about the earlier start, the early finish, and the late start and late finish of doing all the activities in the project. So let's start with the early start and early finish here. Finding early start and early finish requires going from passes from the beginning to the end of project for the activities, whether you are using an AON or AOA network. So what is the earliest start? Earliest start for an activity is just the earliest time you can start that activity. So this means that the precedent relationship does matter, because to start an activity, the preceding activity must have been completed. So it matters how many activities are before the activity that you want to start earlier. Assume that we only have one precedent activity before the activity that we want to start. Let's say that we are working with nodes here. So for nodes with one entering arrows, so suppose that this is the activity that we want to start, and there is only one precedence relationship here. That means that there is only one activity that needs to be completed before we can start this. So we can start this activity. So you can start this activity whenever this activity is completed. So that means that the early start of this activity is equal to the early finish of this activity. What if we had multiple precedent relationships? Suppose there are several activities that need to be completed before you can start an activity. So let's show it by nodes and diagram. Suppose we want to start this activity and there are several precedence arrows here. So this means that for this activity to start, all of these three activities must be completed. So this means that the earliest start for this is actually equal to the maximum or the largest early finish of these activities. So the earliest start is equal to the largest of entering early finish of the precedence relationship or activities. When you compute the early start of an activity, the early finish of that activity is actually straightforward. The early finish of an activity, suppose that we show it by an arrow, activity on arrow. So the early finish of this activity is equal to the early start plus the timing that this activity takes to be completed. So the early finish of each activity is the early start plus the timing, t, the time that that activity would take to be completed. So computing early start and early finish, start with computing the early start, and then early finish is just for each activity is just equal to the early start of that activity plus the timing that activity would take to be completed. Now let's go ahead with the late finish and late start. Before we learn about late start and late finish, let's do an example on computing the early start and early finish. So we have this the same network diagram example, building a new department in a bank, and this is how we proceed. We're going to make this little tiny figure on above of each of the arrows, because this is an activity on arrow network, and T stands for the timing, the time that it takes the processing time or the time that it takes an activity to be completed. And this is the earliest start and this is the earliest finish. So we're going to start from the very beginning here, and then we're gonna go forward from left to right up when we get to the finish point here. So let's go ahead and do this. So now please pause and try to solve this problem before you see the solution and how it is solved. So please pause and work on this problem, then come back to see the solution. All right, this is how we solve the problem. So we start from the very beginning, from node 1 here. And then I'm going to create these little figures here. And I'm going to put the values for the earliest start on the left, down left here. So that's the earliest start. And that's going to be 0. We can start it right away because there is no other activity that goes to node 1. So because there is no activity, we can start right away at time 0. And to compute early finish is equal to early start plus t. So for 1 to 2, the early finish would be 0 plus 8. This is 8. This is t, 8. So that means it's 8. So it's 8 here. Okay. And we do the same for node the arrow 1, 2, 3. So I'm going to open this here, and the starting point would be 0. The earliest start would be 0, and the early finish would be 0 plus the time that activity 1, 2, 3 would take, which is interviewing, and would take 4 weeks. So that's 0 plus 4, which is 4. So this is 4. Next activity, I'm going to go with the activity 3 to 5. That's hiring and training. So I'm going to open up this little box here to put the early start and early finish. The earliest start for this activity 3 to 4, 3 to 5, for this to start, the previous activity, which is 1 to 3, must be completed. And that activity is completed at 4. So this means that the activity 3 to 5, the hiring and training, cannot start before 4. So the earliest start is actually week 4. And the earliest finish would be earliest start 4 plus t here, which is 9. That's how long it takes to complete hiring and training. So that's 4 plus 9, which is 13. So I'm going to put 13 here. Next, I'm going to do activity 2 to 4. So I'm going to open a figure here, this little box here. The earliest start for this activity 2 to 4, the ordering furniture, for this to be completed, we need to have the previous activity, which is locating 1 to 2, must be completed. And the earliest finish for that, that's the 8th week. So the earliest start of this activity is 8. And the early finish for the activity 2 to 4, ordering furniture, is earliest start plus earliest finish. So the earliest finish would be 8 plus t is here is 6, so that's 8 plus 6, which is 14. So I'm going to put 14 here. Next, I'm going to go with the activity of remodeling. That's this activity. So I'm going to open a box here, a little box here. The earliest start of this activity for the remodeling to be completed, we have to be up to the node 2, which is the finish point of locating arrow 1 to 2, which is activity of locating. And that is completed until 8th week, not until 8th week. So that means that the earliest start of remodeling can be 8th week. And the earliest finish is the earliest start plus the time that it takes to complete remodeling, which is 11. So that's 8 plus 11, which is 19. So the earliest finish of this activity in 19. So I put 19 in the earliest finish. Next, we're going to go with the activity 4 to 5, the setup. I'm going to create a little box here. The earliest start for this activity, that means that we have to be end up to node 4. That means that activity order furniture 2 to 4 must have been completed, and that's completed not until the week 14th. So that means that the earliest start of 4 to 5 or setting up is 14. And the earliest finish would be the earliest start plus the earliest plus the time that it takes to complete this, which is 3 weeks. So that's 3, and that's 17. So I'm gonna put 17 here. 17. The only activity left is activity moving 5 to 6. So I'm going to open a box here, and the earliest start for this activity, we have to have got to node 5. That means that all of the activity 4 to 5, 2 to 5, and 3 to 5 must have been completed. So here, that means that for all of these to be completed, so we need to find the maximum earliest finish of these activities. The earliest finish of activity 3 to 5, hiring and training, is 13. The earliest finish of the activity 2 to 5, remodeling, is 19. The earliest finish of activity 4 to 5, setuping, is 17. And the maximum between 13, 19, and 17 is 19. So the earliest start of activity 5 to 6 moving is 19. What is the earliest finish? So earliest finish is earliest start, which is 19, plus T here. That's 1 week. So that's 19 plus 1, which is 20. So I'll put 20 here. So we are done. We are done with the computing earliest start and earliest finish, and you can actually figure out actually the critical path here. The critical path is the path with the longest duration, the longest path, or the length of the path. So that's going to be, of course, this is part of it, and then because 19 here is the earliest, the maximum earliest finish. So that's going to be this, because 19 is the maximum between 13 and 17. So we're going to go with 19 is largest. And then from there, we're going to go with this. So that's the critical path is 1 to 2, 2 to 5, and 5 to 6. And the length of the critical path is 20, which is also the length of the project. So the length of the critical path is 20, and that's the length of the project. This is the final solution for example 2. As you can see here, we have all these boxes completed for the earliest start and earliest finish for all of the activities, and up to the final activity, which is moving, and the earliest finish of this project is 20.